Chapter 6, Part 3. So this is the last video for Chapter 6 before we go to the Chapter 7. Just to remind you that a few assessment has been uploaded into the Kalam, assignment as well as project. So please do it within the given time, and you need also to submit the answer or the report by upload it into the Kalam. Right, so we are still at the pattern recognition or object recognition or classification. So this is also part of the object recognition, but this is more a little bit advanced compared to the previous part of the lecture or previous part of the notes object recognition. This is more to the theoretical, because all the method and all the techniques you can get it from you can get the coding, available coding, so that you can just use any pattern recognition you want in your project, for example, by knowing the theoretical. So you just choose any available coding or function or method in any software that you use for computer vision system development. The assignment of a physical object or event to one of several pre-specified categories. So this is the statement by this guy. A pattern is an object, process, or event that can be given a name. A pattern class or category is a set of patterns sharing common attributes and usually originating from the same source. During recognition or classification, given objects are assigned to prescribed classes. A classifier is a machine which performs classification. So basically, this pattern recognition is same like my explanation on the previous object recognition, previous video. So it is about to analyze attributes or features of an object. So based on the features, we can identify the pattern of the object. Then we can implement or apply pattern recognition techniques to recognize or classify an object. This is an example of application. This is more specific to an application of vision or computer vision. And where is it the pattern recognition? For example, optical character, handwritten, sorting letters by postal code, input device for PDE, printed text reading machine for blind people, digitalization of text documents. So basically, in any or many applications, pattern recognition is a must for classification. Because if you still remember that in order to develop a computer vision or machine vision, there are a few steps required, where the final stage of the machine vision system is decision or classification. Another example in biometrics, face recognition, fingerprints recognition, speech recognition, diagnostic system, military application. So basically, in any application of vision system is required to apply pattern recognition or object recognition. So there are a lot of approach. So among the approach is like, this is an example. We can use method for pattern recognition. Statistical pattern recognition based on underlying statistical model of pattern and pattern classes. Structural or synthetic pattern recognition, neural networks, and there are many more application or approach we can use for object recognition. So this is a basic concept. We have a pattern, and then x1 until xn is a feature vector, a vector of observation. X is a point in a feature space of X, right? So to design a classifier, Qx to Y, which decide about a hidden state based on an observation. So this is an example of pattern recognition. This is a features or attributes of the object, height and weight, and then we give the x1 as x2 feature vector, and then we can use any method to train our data. So this is a training example. We can also use linear classification. Components of pattern recognition, we have object, we acquire the image, sensor and pre-processing, we extract features, okay, classifier and class assignment. So from here we can train our classifier to recognize the pattern of the object. Sensors and pre-processing, a feature extraction aim to create discriminative features good for classification. A teacher provide information about hidden state. A learning algorithm sets pattern recognition from training examples. This is example of feature extraction to extract features from which are good for classification. So good features, object from the same class have similar feature values. Object from different classes have different values. Good features, bad features. Good features is easy to classify. There's a red circle and cross, a blue cross here. There is no overlap. Overlap means that we can easily choose our linear classification here to distinguish object A and object B, okay, or anything that we want to classify. So if we got these features, so this is considered as a good features. There is no overlap. So decision is 100%. But this is bad features. The features of object is not, you cannot distinguish between each others. It's like example of sea bass and salmon in the previous video. So it's difficult to do classification. If you do classification, then it might give you a lot of errors. So this one is considered bad features. So this is a feature extraction method. Problem can be expressed as optimization of parameters. We have a supervised method. We have unsupervised method. So if you have features, then we can perform feature selection. Some of the features may not useful, so that we can remove. This is what we call it, feature selection. So this is classifier, all right. You can see here x1, x2, and x3 we can classify, or like this x1 and x1, x2 and x3 we can also classify. So a lot of classifier method we can use. It's not only just a linear classifier like previous slide. We can use a lot of uh, classifier type based on um, based on how our futures looks like. Okay, so representation of classifier. So this is the way how we represent our classifier. We have a feature vector, we have discriminant function, maximum y. So this is all about how we can design our classifier. So this is a type of classifier. Bayesian decision making is fundamental statistical approach which allows to design the optimal classifier if complete statistical model is known. So we can use on decision make Bayesian decision make. Okay, so I just go through very fast on this one because this is more to the theoretical. So in a feature extraction or in a classification, we have what we call it overfitting, under and underfitting. When we perform classification, we can plot the classifier. So if we got this kind of classifier, we call it good fit. But if we have this type of classifier, straight line here, so this is underfitting because some of the features is not fall into the correct categories, right? You can see the circle, right? It is supposed to be under the linear line here, linear classifier. Okay, and the last one is overfitting. So you have a very difficult, you know, classifier. So we call it overfitting. Okay, so this is also a theoretical structural risk minimization, theoretical of classifier. I skip this one. Okay, in order to train our classifier, we have what we call unsupervised learning. Okay, a broad class. We have input training example without information about the hidden state. Clustering goal is to define cluster of data sharing similar properties. So a broad class of unsupervised learning algorithm, classifier learning algorithm. So this is we call it unsupervised learning. Okay. So next, neural networks. You learn this detail in other subject, if not mistaken. But this is on for this subject. This is just like a theory knowledge or basic of the neural network. What is neural network? Ideas stem from the operation of human neuron. Network is interconnected nonlinear computing elements called neuron. So in neural network, we have perceptron, two classes model. So this is a structure of perceptron of neural networks. So this is basic structure of multi-layer feed-forward neural networks. In neural network, we have our training algorithm. There are a few method of training algorithm like back propagation, sigmoid activation function. Okay, so this is